All right, welcome. We are going to be starting a chapter on inverses and radicals, as you can see here. So let's find out what our learning goals are for this first section. We want to be able to find values and rules for composites of functions. Now, if you remember, we had worked with these composites previously in another chapter. So we're going to go forward and go right into what we should remember. Compositions of functions. F little circle g is the symbol, and it's the result of first applying f, then applying g to that result. When we read that little combination, g little circle f, it's g follows, is how you read that little circle, f. So it's telling you the order which you want to perform this combination. Now, if you remember also, we've had arrow notation, f of x notation. So on this next part of the slide, you're seeing just that. Over here is what we used to call arrow notation. I have g follows f of x, after the colon is the variable being used. Then we see an arrow standing for the arrow notation. At the end of the arrow is the rule that you want to do. And in this case, it says g of f of x. Now remember, this is not multiplication. Okay, so you don't want to take x, times it by f, that answer times g. That is not what that stands for at all. Remember, in our functions, usually f of x is the name of a function, and then you'd have something, and then g of x is a name of a function. And those functions, for example, could be nothing more than maybe a linear combination. Maybe it would be quadratic. So just rules, combinations of things that we need to work out, assess, evaluate, and it is read g of f of x. So knowing that, let's go ahead and try to evaluate, simplify a couple functions. Now, as always, you are going to have to be given some functions. So take a good look at the top. We've done that. We've given you an f of x rule. Looks to me like every time you want to use f of x, you're going to take 2 times your number and subtract 1. And you've also been given a g of x rule, which says you are going to take 1 and divide it by your number. All right, with that, you're going down to the work, and it says f little circle g. Now, you're not going to read it that way. You want to say f follows g of f. If you want to write it like we have in the past, you would want to say f parenthesis g parenthesis 5. Meaning, we're going to start with the number 5, and we're going to put it into the g rule. So that's what you're going to see me do first. So there's the 5. It goes into the g rule. The g rule is nothing more than 1 over x. Well, our x value is 5, so we now have done g of 5. G of 5 is the number 1/5. Now you have to take that result, 1/5, and put it into the f rule wherever there's a variable. So now, putting it into the f rule says take 2 times your value, and our value currently is 1/5, and subtract 1. So if we do the math here, we know whole number times a fraction should be top times top, bottom times bottom. So 2/5 minus 1. If you have 2/5 and you subtract 1 whole, what do you get? Think of it like in cooking class. Just remember, though, that your 1 whole is negative. And when you do this, you can think of that 1 whole in fraction form. If you do, you want to remember that the common denominator is the key. So if that helps you, 2/5 take away 5/5, and 2/5 take away 5/5 leaves you with a negative 3/5. Check your work. We have, and again, we get the result. Okay, now you're saying, well, what if I give you the same thing but maybe a different direction? And that's all we have here. I'm still evaluating at the number 5, but this time it's g of f of 5. Some people would go ahead and say, well, I did that over there, so I know it's the same combination. I'm going to say, ask yourself, does changing the order of the function change the result of your answer. So we're going to try that. G little circle f means G follows f of x. In this case, x is 5. So G follows f of 5. So find your f function, and we will from there take 5 and put it into our equation. So 2 times 5, subtract 1. 2 times 5 is 10. 10 take away 1 leaves us with a 9. So we have G of 9. G of 9 means put 9, your result, into the G rule. And our G rule was nothing more than 1 divided by your number. Well, our number is 9, so we'd end up with 1/9. Now take a look right away for those of you who thought they'd be the same. I've got a negative 3/5. I've got a 1/9. Not looking like it. So, and if you're checking, there we go. Just proves that they are not the same. So order does matter. Obviously, we're putting in the same value, 5 on both of them, but the order that you place them into the different rules does make a difference with the result. All right, next one. 2 new rules, so take a look at them. We've got P of x is the rule, take your value x and square it. So you can see that here. And then Q of x is nothing more than take the opposite of x and add 1. So in each of these, the difference here in example 2 is that I did not give you any numbers. So you have to work with the variables as is. So we're going to rewrite them just like we did, but we'll have to keep the variables in our work. So P of Q of x. So look at your rules. Where is Q of x? Ah, right there. And Q of x is nothing more than the opposite of x plus 1. Now you must take the P rule and put in the opposite of x plus 1 wherever there's a variable. Oh, and the P rule is nothing more than take what your number is, opposite of x plus 1, and square it. Now we have a shortcut rule for a binomial square, or you could FOIL. I'm going to use the shortcut on this example. That would be, take the first term and square it. That would be x squared. Take the product of the two, negative 1x. Double it, negative 2x. Square the last, 1 times 1 is 1. And so we would get x squared minus 2x plus 1. In the other setup, again, we learned from the last slide that just because it's the same functions, just different order, doesn't mean you will want to just write the same answer. So we need to evaluate, but this time the order changes. So Q of P of x. Again, we do not have a number to put in, so we have to work with the general rule as our guide. So P of x. P of x is nothing more than take x and square it. So we are replacing. Our P of x rule is x squared. Now we need to take Q of that number. That number is x squared. So wherever there's a variable in the Q rule, we need to put in our number. So our rule is the opposite of x, and x is now x squared, and we will add 1 to it. So the opposite of x squared is definitely a negative x squared, and add 1. It's not opposite of both. It was only opposite of our number, and our number was x squared. Okay, so you can see that they definitely do not look alike. Let's do a little check to make sure we're on board. The only thing, I see that one matches exactly, as does that one. I was going to say the only thing you might see different is sign changes, plus a negative, but we didn't. They were matching exactly. Okay. Now, it says let g of x equal, and you see your rule, and f of x equal, and you see your rule. Oops, didn't mean to do that. So if we have our rules here, make sure you're looking at them in their entirety. It says find a restriction on the domain of g follows f. So let's write that down first. G follows f would be nothing more than g of f of x. And yes, a restriction on the domain means what can you domain, what are all possible values of x. But restriction means maybe there is something that doesn't work for x. So let's look at it with our function rules put in. So I know f of x, based on our descriptions up top, f of x is nothing more than x plus 2. So we're going to take whatever our number is and add 2 to it. Now, g of x plus 2, we have let's put it in, and into the rule now, we have to put 1 over 2. Our variable is our number that we just assessed, which is x plus 2, and then we have to subtract 1 from that. That's all in our denominator. So carefully, let's simplify. We still have the numerator of 1. In the denominator, we have 2x plus 4, subtract 1. And 2x plus 4, subtract 1, the only thing we can do is the adding and subtracting. And so final reducing, we get 1 over 2x plus 3. Okay, so if we had to simplify it like we were doing on the last ones, we'd be done. But because the question's a little different, find a restriction on the domain of g of f. So when we did this, and we got our answer of 1 over 2x plus 3, you should be noticing that your variable is now resting in the denominator. And you should have a slight issue with that because you've learned, and we've reviewed it in this class plus other classes, that in a fraction you have to be wary that your denominator cannot be 0. We know that 1 over 0 is not possible, cannot be done, does not equal anything. We would say it's actually undefined. So I don't want to say is not equal to undefined, but it's undefined. It cannot be done, impossible, no solution, or other things we've said. So at this point, you better take that denominator of 2x plus 3 and set it equal to 0. Why? You need to find out what is going to make that a 0. And whatever makes it 0 is our restriction, because we're saying we can't have a 0 in the denominator. So finish the math. We'll move the 3 to the other side, make it a negative 3. We'll divide by our 2, and we will get x equals a negative 3 halves. So our restriction to the question that was asked is x cannot equal a negative 3 halves. If it does, then we have an impossible problem that we're working on. So the restriction is what makes the denominator 0. By solving it for 0, we found that restriction. Okay. You're going to have to watch out for that only when you have a fractional look in your function. If you don't have a fractional look and everything looks to be in the numerator or looks to be a whole number, then you should be good. Okay, bring any questions you have to class and we'll discuss them further.